Okay, hello class. Welcome to trigonometry. I'm going to go over a few topics and problems. We'll start off with section 1.1. So in section 1.1 we have angles, and we want to talk about angles and their properties. So segment AB, that's a line segment. We have which is just a piece of a line. The whole line is line AB. We have a ray AB, and we usually call it AB instead of BA here because it's going from A through B, and A is the endpoint, and so rays only go one direction. Okay, an angle has a vertex A, and then a terminal side and an initial side. So the initial side is where we start, and then the terminal side is where we end, and the amount that we rotate is the size of the angle. The degree of measure, we chop a circle into 360 equal pieces, and that's one rotation. So we measure angles in degrees. Later we'll talk about radian measure as well. Okay, types of angles. Acute angles are 0 to 90. The way I remember that is they're acute little angles, cute little angles. Obtuse is more than 90 to 180. A right angle, okay, is a 90-degree angle, and a straight angle is just the angle measure of a line, and that's 180 degrees. Okay, so we want to find the measure of each marked angle here. We have a right angle and we have a straight angle. Okay, and for the right angle, these two angles are what is said to be complementary. Two angles are complementary if they add to 90 degrees. So we're going to say that these two angles, 2x and 3x, they're complementary. And so we want to find out how much are the angles. So I know that 2x plus 3x has to be 90 degrees. So 5x is equal to 90 degrees. I'm going to divide this by 5. And I get x is equal to 18 degrees, or just 18. And so we want to find out, well, what's 2x? This x just represents the variable, but it's not really the angle measures. So what are the angle measures here? 2 times 18, oh, that's 36. Okay, degrees, and 3 times 18, that's 54 degrees. Okay, and so 36 plus 54 does equal 90. So we could check that real quick. 36 degrees plus 54 degrees, that does equal 90 degrees, so that checks. Okay, so the angle measures that we're looking for was this 36 degrees and 54 degrees. Okay. Okay, what about the straight angle here? This angle has 180 degrees. So 7x plus 2x is 180 degrees. So 9x is 180 degrees. Divide by 9, and we get x is equal to 20. So 7 times 20 is 140 degrees, and 2 times 20 is 40 degrees. So this is 140 degrees and 40 degrees. And do those add up to 180? Yes, they do. That's pretty easy to see. Okay, so 140 and 40 they're definitely going to add up to that straight angle 180. Okay, we talk about portions of a degree in terms of minutes and seconds. Okay, so 1 degree is made up of 60 minutes, and 1 minute, 60 minutes, and 1 minute is made up of 60 seconds. And so there's 3,600 seconds in a degree. So the little apostrophe there, 1 apostrophe means minute. Okay, so minute. And 2 apostrophes means seconds. Okay, so 1 apostrophe is minutes and 1 apostrophe is seconds. So we want to add the minutes and the seconds. Now, keep in mind that these are 1/60th, and 1 minute is 1/60th. So when we think about the minutes here, they're really in terms of 60s. Okay, so this is 28 degrees. Okay, plus and 35 minutes plus 63 degrees and 52 minutes. Okay, well, let's add up the minutes. If I do that on a calculator, okay, 35 plus 52 is equal to 87. Now, 87 is bigger than 60. Okay, this is bigger than 60. So it is 87 minutes, but think of, a clock, right? If you have 87 minutes then you're going to have 1 hour and 27 minutes. So this really is 1 degree. This is 1 degree, 27 minutes. Okay, so we kind of have to carry that 1 degree over into the degrees column. So we have 28 degrees, 63 degrees, plus this 1 degree. If I, oops, sorry about that. If I add 28 plus 63, plus that 1 that I got from before, I get 92. So this is 92 degrees and 27 minutes. Okay. Okay, let's look at this. This is 180 minus 117.29. So what I can do here is I can borrow. I can say that this is really 179 degrees and 60 minutes minus 117 degrees and 29 minutes. So now I can actually subtract. So I'm going to line this up, 179 degrees, 60 minutes minus 117, 29 minutes. So 60 minus 29. Okay, so what's 60 minus 29? 31. Okay, so that's 31. And then 179 minus 117 is 62 degrees. So that's 62 degrees and 31 minutes. Okay, example 3, convert this guy to degrees, to the nearest thousands. So this, we can take the 105 degrees plus the 20 minutes. Now I know that that's out of 60, 20 out of 60, plus 32 seconds, but 32 seconds to the nearest degree, 32 out of 3,600. There are 3,600 seconds in a degree. So I have 32 seconds over how many seconds are in a degree. That's going to give me the fractional part of how many seconds are in 1 degree. And so this is 32 out of 3,600. So I'm going to plug that into the calculator. Let's move this over. Okay. And we're going to say, well, it's 105 plus 20 divided by 60 plus 32 divided by 3,600. And that's 105.342. So they're wanting us to go to 3 decimal places. So 105.342 degrees. Okay. Now this guy is interesting. It says convert 85.263 to degrees, minutes, and seconds. Okay, so I know that this is 85 degrees. Okay, that's, let me just write So we have 85 degrees. We just want to know what the 263 is in terms of minutes and seconds. What I'm going to do is I'm going to say, well, what's 0.263 of a degree? 0.263 of a degree is, I'm going to multiply that times 60, 60 minutes in a degree, right? So I want to know how many minutes is 0.263. So when I multiply that, I get 85 times 0.263 times 60. Oops, not 80, sorry, not times. Let's clear that. This is, let's just do 0.263 times 60, just do the 60, and I get 15.78. So 85 degrees plus 15.78 minutes. Okay, but now we have this 0.78 minutes. And so what we can do now is we can say, well, this is going to be 85 degrees plus 15 minutes plus 0.78 times, we're going to do 60 again, because that's the number of seconds in a minute, because this is a fractional amount of minutes. This is a less than 1 minute. And so I want to know how many seconds makes up 0.78. And so we get 0.78 times 60 is 46.8 seconds. So 85 degrees plus 15 minutes plus 46.8 seconds, and they want us to round to the nearest second. So this is going to be 85 degrees plus 85 degrees. I don't need the plus anymore. 85 degrees, 15 minutes and 47 seconds, roughly. Okay, so let's talk about angle measures. Okay, in degrees. An angle is in standard position if the vertex is at the origin and its initial side, I'm gonna put that in blue, its initial side lies on the x-axis, okay, and the positive x-axis. Okay, so it starts here, that's the initial side, and then wherever it lands, wherever it ends, that's the terminal side. Okay, but this is standard position for an angle. Standard position. Okay, and angles whose terminal side lies on an axis are called quadrant angles, and there's 4 of those quadrant angles. Okay, so if we start here and we go to a quadrant and it lies on an axis, let's talk about the first y-axis it hits, then this is a 90-degree angle. Okay, if it goes to a full, the x-axis, again, that's a straight angle, and so that's a 180 degrees. If it goes past 180 to the y-axis again, that's 270. Okay, so I'm going to put this down to where it actually lies. So this is 180 degrees. This is 90 degrees. Whoops, sorry about that. Okay, this is 90 degrees. That's 180 degrees where it's on the axis. Okay, we call this 0 degrees if there is no movement. That's 0 degrees. And then if we go all the way around here, this is 270 degrees. And then if we go all the way around the circle, then that's 360 degrees. And so 0 degrees and 360 degrees, they're the same angle. And they're called coterminal angles. So it says angles with the same initial side and terminal side. Basically, they end up at the same spot, but different amounts of rotation are called coterminal angles. We're going to look at some coterminal angles here. Okay, we want to find the coterminal angle, the least positive coterminal angle. And so the least positive coterminal angle is going to be an angle between 0 degrees and 360 degrees. Okay, so the smallest positive coterminal angle is going to be within that range, okay, 0 to 360. So we have 1106. Well, that's outside this range. So what I'm going to do is I'm going to chop it down by 360s, because if I have an angle, say this angle here, and I want it to be coterminal, well, what am I going to do? I'm just going to go around the circle. And so say that this was a 45-degree angle, then a coterminal angle would be that plus 360. So 360 plus that is what, 405? Okay, and so 45, 405, and then we could just keep adding 360s. Well, I could do this process in reverse by subtracting 360s. If the angle is too big, I just subtract 360s. So I'm going to take 1106, I'm going to subtract 360 until it gets in this range. Okay, I'm looking for it to be in that range, 0 to 360. So let's chop it down by 360 degrees. So I get 11. Oh, move for me, thank you. Okay, 1106 minus 360. Okay, is 746. That's still too big. So I'm going to chop it down again. 746 minus 360. That's 386. That's still a little bit too big. We want it to be less than 360. So let's go 360 again, and I can do that one in my head. That's 26. So that's 20. So the smallest coterminal angle was 26 degrees for that 1106. What about if it's negative? What does it mean to be negative? Negative 150. Where would negative 150 be? Well, positive direction goes counterclockwise. Okay, so positive angles counterclockwise. What about negative angles? They go the opposite direction. They go clockwise. So counterclockwise is positive, negative is clockwise. So if I were to go negative 150, that would be this line, this axis here, instead of being positive 270, would be negative 90. Okay, because I would go negative right angle here. And so that's a negative 90. They're the same thing. They're coterminal. 270 and 90 here are coterminal. If I went into this third quadrant, so again, the quadrants are 1, 2, 3, and 4. So those are my 4 quadrants from algebra. Okay, if I went into this third quadrant, then I'd be 150 negative. So what is going to be coterminal to that? Well, all I have to do is add, this time, 360. If I add 360, I will go right back to where I started, but it'll be a positive angle. Okay, so if I take negative 150 and I add 360, I'm now at 210. And so 210 is the positive coterminal angle to negative 150. Okay, and that lies in my 0 to 360 as well. So I'm good there. What about negative 603? Negative 603, we're just going to keep adding 360s until we get something in this range. Okay, so 603 plus 360, 603 plus 360. Oops, sorry, it's negative 603. So 603 negative plus 360 is negative 243. Okay, and then that's still not positive, so we're gonna add 360 again. Oops. Okay, let's add 360 again. Negative 243 plus 360. Okay, is 117, positive 117. Okay. Okay, let's do one last problem from this section. Okay, a wheel makes 270 revolutions per minute. Okay, so 270 revolutions for every 1 minute. And it says how many degrees will a point on the edge of the wheel move in 5 seconds? Okay, so we want to know, well, how many degrees are in one revolution? If I go all the way around a circle, that's a revolution. Okay, if I take a circle here and I go all the way around the circle, oops, back my circle here. Okay, and I go all the way around, that's 360 degrees. So it's saying that I'm going to go 270 revolutions, and there's 360 degrees in one revolution. And the way that I reconcile these units is just multiply by, one revolution. Just multiply by how they're related. Okay, by the proportion that they're related. So 270 revolutions in 1 minute. Now I'm going to multiply to deal with the revolutions to get it to degrees. That's 360 degrees in one revolution. And now I have to deal with the minutes. I want to make that into seconds, right? So 1 second, okay, 1 second is, or sorry, 60 seconds is 1 minute, right? And so I want to cancel the minutes. So I'm going to put 1 minute is 60 seconds, okay? And this will give me how many degrees. I'm going to cancel out the units here. How many degrees per second? This will allow me to write it in degrees per second. And this gets me 1620 degrees, okay, degrees in 1 second. Okay, so if I multiply this all out and divide, I'll show you. This is 270 times, okay, 360 divided by 660 is 1620. So that's 1620. And what I'm going to do with this guy is I'm going to now multiply him by 5 seconds. Okay, so times 5 seconds. Okay, and that will give me the number of degrees in 5 seconds. And if I multiply that, 1620 times 5, I get 8100 or 8100 degrees. 1,100 degrees in 5 seconds. Okay. Okay, so I'll see you in the next section.